So a pentagonal pyramid of 25 mm sides of base and 50 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and to VP at 30 degrees. Now here, so since it is resting on rests on HP, so obviously we have to start the problem from HP. And since it is resting on one of its corners of the base, whether it is resting on corner or the base, always the base edge has to be perpendicular to VP. So we are considering perpendicular to VP, and all the edges are resting on HP, so therefore it is parallel to HP. So when you look from the top view, I can see a pentagon of 25 mm sides, and such that two base edges containing the corner on which it rests make the equal inclinations with HP. So since it is the corner is A, so the two base edges containing the corner is AE and AB, which makes equal inclinations with HP. So it is making an equal inclination here. So equal inclinations here. So in this side, that is in this edge, this side is a corner and this side is an edge, and that means this side is a slant edge and this side is a slant triangular face. Since it is resting on corner, so this side we have to rest on corner. So once you rest on this corner, so we have to rotate in anti-clockwise direction. Now once you look from the top view, ABCDEA is the one which is visible. So we have drawn that ABCDEA is visible. And when you look from the top view, OE join between OA, OB, OC, OD and OE, join between OA, OB, OC, OD and OE. These are called slant edges. Similarly, OAB is a triangular face, OBC is a triangular face, OCD is a triangular face, ODE is a triangular face, OEA is one more triangular face. So we have 5 triangular faces for a pentagonal surface. Similarly, when you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible. D and E is away from the observer, so D dash, E dash is invisible. And O1 dash is invisible because that edge VBC is hiding that particular point O1 dash, and that is invisible. So when you look from the front view, the height of the pyramid is visible. So from this point you measure, you make that 50 mm height which is visible here. So O dash becomes visible. So you join them with the dark lines here as shown. So now we need to write how to write this in an orthographic view. So in order to write it in an orthographic view, consider a vertical line of a distance of 25 mm. So as explained previously, you mark the point C and D. From C you measure an angle of 108 degree included angle and draw a line, this line. Similarly, from the point D you measure an angle of 108 degree by included angle by using the protractor, and then you draw a line. Then by using the compass you measure the length of 25 mm. From C you cut an arc on this to get the point B. Similarly, from D you cut an arc on this to get the point E. Then from B you draw an arc of 25 mm again by using the compass. Similarly, from E you cut an arc on this to get the point A. Once you get all the 5 points, then you join them with a dark line to complete the sketch. Now we need to find out the center. So then we have to have the angular bisector. So by using the protractor you measure an angle of 54 degree with respect to CD, and then you draw a line. Similarly, with respect to CD, from D with respect to CD you measure an included angle of 54 degree and then draw a line, and join OD. So these two lines will going to intersect at this point, so you are going to mark that point as O, and now you dark them OC and OD. Once you mark them, then once you dark them, then from O you join to A, then O to B and O to E with a dark line, so that we will going to complete the pentagon, such that the two base edges containing the corner on which it rests makes equal inclination with HP. So automatically AE and AB will going to have equal inclinations. So from here you draw the front view. So you join all the points to the XY line. Then you will, when you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible, and D and E is away from the observer, so D dash, E dash is invisible, and O1 dash is hiding by the edge of B dash, C dash, so naturally that becomes invisible. When you look from the front view, So we can see the height which is 50 mm axis length. From O1 dash you measure a height of 50 mm and then you mark this point O dash. Then join O dash O1 dash with a center line and then join O dash to A dash. Visible to visible is visible, so you dark this. O dash to B dash is visible to visible is visible, so you dark this. O dash to C dash is visible to visible is visible, so you dark this. So A dash to B dash is visible to visible is visible, you dark this. Similarly B dash to C dash, visible to visible is visible, you dark this. So once you get this triangle in the front view, then he says it is resting on corner, so we will go to rest on corner such that the axis is inclined to HP at 40 degrees. Now in the second position, since it is resting on one of its corners, so we will going to represent A dash on the XY line such that the two edges containing the corner makes equal inclinations. So the corner is A, the two edges containing the corner is AB and AE, which will always makes equal inclination here also with respect to HP. So from here, first is you draw a line which is inclined at 50 degrees to the XY line because the axis is inclined at 40 degrees. So first, by using the protractor, consider any point A dash with respect to C dash D dash at convenient distance. From here, by using the protractor, you measure an angle of 50 degree and then draw an inclined line. So from A dash, by using the compass, you measure the length from A dash to D dash. From A dash, you cut an arc to get this point C dash D dash. Similarly, you measure the length from A dash to O1 dash. From A dash, you cut an arc on this to get this point O1 dash. And then you measure the length from A dash to B dash. From A dash you cut an arc on this to get this point B dash A dash. Then you O dash O1 dash is perpendicular to A dash C dash. So from O1 dash line, from O1 dash point, by using the protractor you measure an angle of 90 degree with respect to A dash C dash and then draw a perpendicular line. And from here, from O1 dash you measure a height of 50 mm. So from O1 dash you cut an arc on this to get this point O dash. And then complete the triangle as shown for exactly similar to the one which has been drawn in the first position front view. Then you need to write the top view. Since you need to write the top view, so draw a vertical projector from O dash and draw a horizontal projector from O to get this point O. Similarly, draw a vertical projector from A dash and draw a horizontal projector from A to get this point. Then draw a vertical projector from B dash E dash and draw a horizontal projector from B and E to get this point BE. Similarly, draw a vertical projector from O1 dash and draw a horizontal projector from O1 to get this point O1. And draw a vertical projector from C dash D dash and draw a horizontal projector from C and D to get this point CD. Once you get this point, once you get these points, name them A, B, C, D, E, A and O. Then join them with a continuous thin line. Join AB, BC, CD, DE, EA and OA. Similarly, OB, OC, OD and OE with a continuous thin line. Then we will going to apply the condition of visibility. So here all the exterior edges of the boundaries of the solids are visible. So which is the boundary? OB, BC, CD, DE, EO is on the boundary. So you dark them. Then once you look from the top view, O dash, C dash, D dash is a triangular face which is visible because when you look from the top view, OCD is near to the observer, so it becomes visible. So you dark OC and OD, which is a dark line. Now the question is left out with AE, AB and OA. So since AE is crossing the visible edge OD, so AE will becomes invisible because the two visible edges can never cross each other. And the same explanation is holds good for OC also, wherein OC is a visible edge, so naturally AB will going to become invisible. From a point, if any of the one edges becomes visible or invisible, automatically the other edges emanating from that point is also invisible or visible. So apply that rule. So from that rule, if you consider a point, from AE is invisible and AB is invisible, so naturally OA also becomes invisible. So OA will become invisible. Since when you look, since in the pentagon AB and AE becomes invisible, any one of the edges becomes invisible, so automatically since O1 is on that surface, automatically that will also becomes invisible. So O1 will be in bracket. And since OA is been invisible, from A to this point you make it a center line here. Okay. Then this is also evident when you look from the top view. This triangular face is hiding this O1. So naturally O1 will be invisible.